Hi, welcome back to Future Fast. And once again, we have Professor Susan with us. And for those of you who are here for the first time, I urge you to go back and listen to the first part of the conversation because that's where she shares her journey. And I think it really helps you if you have an understanding of where she comes from. And you'll be able to catch on to it because we will be discussing primarily about her book in this part of the podcast. And for you to get where she comes from will be there in the first part. So please listen to that first and then come back, and then you'll be able to appreciate it fully. So with that, once again, Professor Susan, thank you so much for making time to be here with us on Future Path.
Well, thanks. Good to be here.
So, to be fair, I've obviously not been able to pick up things completely out of the book uh, uh, because it just needs so much more time, and I've only taken perhaps half of the book from a point of what we can discuss today. So, for the listeners and the audience, once you hear this conversation, I'm sure you will be motivated to go and pick up the book. But even otherwise, it's not a complete justice from that context. So, I want to place that on record with you, Professor, so that it's just from a point of making good of the time. And also for the listeners, it's really important that you go to the book because one, it's a very easy read, and two, it's loaded with a lot of statistics and infographics, which makes it very easy to understand the whole thing. So I think you will find why you should pick up after this conversation. But so with that, let's just jump into the conversation. I want to start with this. Uh, you propose this as the challenging the idea of sustainable growth in the book. So, so I want to start with what is your idea behind challenging that idea of sustainable growth?
Right. Again, if you agree with the premise, which the introduction story to the book is a thought experiment about how we perceive the definition of a problem or a quandary, and how, if we can flip the perspective over, if we can get down to what's actually making something work, then we can find a surprising and often simple next step that changes the future. And so that sort of came out of a conversation I had with my son when he was a young boy, where he was worried about climate change. They'd watched The Inconvenient Truth in his school. He was quite concerned, and he wanted to know that the sustainable energy stuff that I was working on, renewables and sustainability and stuff like that was going to fix it, right? That the future was going to be okay. And
at least that was the narrative and intention as well, to be fair.
Yeah. And I think I was probably in one of those bubbles where, you're just heads down working away on the technical aspects of something. And to have your son, a little boy, ask you, well, is that going to make it okay, Mom? And then I had to really think, well, is it, right? Is this good enough? Will this save my son, right? And that honesty that no sustainable growth will actually make it worse. And so I sort of had to admit that this pursuit of sustainability and sustainable growth, that it wasn't changing the thing that was putting the future at risk. So I had to tell him, no, it probably won't. If me and everybody else like me are successful, we'll keep doing what we're doing, really. It's which I think has been borne out by the last 20 years, that more of the same gives you more of the same. And so my son, being a bright lad, didn't leave it at that. He said, well, Mom, then you have to figure out what to do. And so that kind of a challenge, you just, there was no government agency putting out funding for people to figure out, well, what do we actually do then? If we question this belief, this communal belief that we all have in these few words, sustainable growth, and we look objectively at how our systems work and what they're actually doing and how you would change them so that we can all survive this journey, then what would that even be that we're doing? And so my son would keep asking me every couple of months, Mom, what are you doing? Have you figured it out yet? And so I thought, well, we have to apply the rigor, the science, the math. We have to apply the fundamentals, the philosophy of engineering, which is that you go from the point of knowledge, observable knowledge, and let's do that, but let's apply it to the question of how do we change the incumbent systems that we already have, and let's just believe that we can, and then we'll see how we could do it. And so that challenging sustainable growth was way more about challenging the philosophy of that it somehow exists, when in fact it is the problem. So throughout transition engineering, what we're going to see is that same thing, where imagine you have a piece of paper and you're looking at it and you can see what's on it, and it's all very clear and everything, and we're all good. But we're going to flip that paper over and we're going to see what's on the other side. And just because we can, it's a step, it's a thing we're going to do. And questioning sounds like radicalism or something, but it's more the counterfactual, which, if you want to feel more comfortable in business, we know that the counterfactual is a very important part of business management. That, okay, here's, you can talk yourself into stuff really easily. So you should always examine the counterfactual. Well, what if that isn't true? What if that doesn't happen? Yeah. So that's.
But unfortunately, there is so much of this popular worldview and narrative, which is also built in this cancel culture, right? So if you're questioning, you're canceled. If you are questioning, these are established fundamentals, and if you're questioning, then you're unscientific. I mean, they decide. So how do you handle that? Have you come across such arguments?
I think because transition engineering isn't a movement per se, or a protest movement or anything. It's a engineering approach, and that means it's a discipline, and that discipline simply requires the factual crash testing of our assumptions. So we call it crash testing because society's glad that we crash test things, right? We failure test things so that we know how strong materials are and how fast you should go around that corner, right? We look for those things. So if we don't crash test our assumptions in other areas, then we're just negligent. So we just do it.
How do you, listening to you, I think it would be so appropriate, as much as the social studies are so important, right? For every branch of education to have an opening to that. I think somewhere this kind of thinking is also equally necessary, no matter what you study, right? So that way, people don't get swayed by what is a popular narrative, and try to approach it a little more scientifically, or in the way you put it, as an engineer would do, right?
Well, here's the thing. If you agree with this premise that we are on a runaway train, right? We've built the tracks really well, we've built the train really well, but somebody has decided that train should go faster every year. And when we start to wonder, well,
there are enough theories for it, right? Which drives every.
Well, it's better to go fast, so let's go faster all the time.
No, but some of these flag bearers are great engineering minds. These are inventors who built it. This was not economists who gave the theories. In fact, they were engineers who gave the theories. Moore's law and so on and so forth, right? So,
Yeah, maybe. Well, I was just going to say, when we start to perceive that maybe this journey we're on is going too fast, that maybe it's not, things are starting to come apart. Be careful, because there will be a clown coming down the aisle selling fun balloons to distract us from this fear. So that's the journey we're on.
right. So
Right.
another thing which is really caught my interest, and while I could get the context since I was reading, but I would like you to share your perspective on that about help people understand your reference to 2 degrees centigrade of failure limit. Uh, so
Right. Well, again, I'm kind of old enough to remember the Kyoto Protocol, and the all of these COPs. We're up to 28 now, right? The meetings about climate change, and the earnestness with which people really thought, well, this is it. This is the one that's going to do the trick. And in 2000, after the Kyoto Protocol, countries were struggling with, the politicians were struggling with, well, okay, we have agreed to reduce our emissions to below 1990 levels by 2012. We all agreed to this. I mean, this was what we agreed. And so they were struggling with, well, how do we do that? And so their choices were carbon tax or carbon trading. Those were the two things. They never once turned around to look at the engineers in the room and say, okay, what does this look like when we're reducing our emissions? And the engineers would go, okay, I see emissions. And I'll tell you what, that's actually fuel. So it's kind of obvious. We need to make our economy much more efficient, much more organized. We need to roll back the just-in-time shipping, because while it was great, it doubled our fuel use. So yeah, we'll just do that. We'll just get onto that. So we could have done that 23 years ago, 25 years ago. But no, we just kept saying emissions. And carbon tax. Anybody have a carbon tax? Not really. We did have a carbon tax in 2008. We had a doubling of the price of oil.
Well,
Did that fix it?
incidentally, there are new arguments for that now.
Of course, you can just keep repeating it. What I'm saying is we had a natural experiment. In 2008, the price of oil went to $140 a barrel. So we have an experiment there where we can see what the effect of a very massive carbon tax on oil would be. And what we see is that it possibly flattened the demand for oil, but it certainly didn't reduce emissions. It didn't, whatever the fundamental changes within our systems were that should have been rejigged at that point, they weren't. So yeah, I think if you're looking from the top down, from the car on this runaway train where all the politicians are sitting, you see a lot of sort of cycle babble. So we're going around and around and around. When actually there's an engine room up front where the fuel is going into the engine faster and faster and faster. That's what's making it run away. And there are brakes and there are instruments. And there's a few people on this train who could actually slow it down. Only a couple, one or two, that could save us all. But they're the ones who are in the engine room. The politicians and the media people and the economists and whatever, they will figure out how in the world we will survive on a train that's not going to wreck. It'll be fine. They'll be able to figure it out.
Can you give some perspective on peak oil?
Peak oil. Oh, you did actually ask about the 2 degrees failure limit. All right.
Correct.
So we need to backtrack there because this is important. So we agreed that we've had these COPs, these agreements, these treaties, these national commitments. We keep having these things, and think about the word that is used for these things, like 2 degrees C, 1.5 degrees C, 350 parts per million. Remember that one? That was one of these. The below 1990 by 2012. We have these things. What are they called? They're called targets, right?
Correct.
A target is a thing you aim for and go towards. You want to hit it, right? All right. Well, this 2 degrees thing, if you look at the science behind it, the loading up of the atmosphere with carbon dioxide higher and higher and higher, which is loading up the ocean with more and more carbon dioxide, which is acidifying it. You know, if you look at this loading and you look at what the science is saying, the modeling of those systems, when you get to 2 degrees C, you have essentially just such broad failures across the system, or a 60% chance of such broad failures across the multiple systems, that you have catastrophic global warming. You've reached tipping points. Things have been overloaded. And in engineering, we call that the failure limit, right? So imagine a elevator, and it has a plaque on it that says what the safe load limit is, right? 1,000 kilograms. Okay. Is that a target? Should we try to load up to 1,000 kilograms before we use it? No, don't do that. There's a chance of something bad happening. And in the design of that elevator, there will be a failure limit, like 3,000 kilograms, right? By the time you get to 3,000 kilograms in that elevator, there's a 60% chance that something will fail in that. And you could have loss of life. You could have catastrophic failure. And so if you look at the mathematics of what the climate science is saying, that 2 degrees is an ultimate failure limit. And if we keep pumping fossil carbon out of the ground and putting it into the air, we will hit that failure limit. And, you know, they can't tell us what will fail first, or how the failure will occur. It's like, well, what does it look like when our elevator fails? You know, maybe it gets stuck halfway down and we don't all die, but it's still really bad. It doesn't work anymore the way it was supposed to. We can't take it up and down the building anymore. So yeah, I think that we need, well, at least for engineers, we recast those targets into limits, because we understand safety limits and failure limits, and that they're hard stops. They're just, no, we don't do that. That's what the climate scientists mean by that. And the story behind that is that I was at a meeting with one of the top people in the IPCC, and he was just so depressed by the fourth assessment report models that were showing, you know, how bad it already is. We've already passed this 350 parts per million, where we told the world that the climate would change if we went above 350 parts per million. How can we make people understand? He said, you know, why are they not hearing us? We just keep like, And I said, well, you know, it sounds like a safety limit to me, the 350 parts per million, that if you exceed that safety limit, something about the system will change in a way that doesn't fit the safe operation anymore. And people shouldn't expect that you could tell them exactly what that is. You've just put this system into an unsafe operating mode. And then, yeah, he was talking about then the budget, the carbon budget. And I said, well, to me, that sounds like a failure limit, like a load to failure. And so maybe we should talk about that. So in the book, I use a cartoon that I sketched up with him over the course of an afternoon, just thinking about how you would communicate this differently. And at that point, I was thinking that if the 2% of people who work in engineering, in making our engineered systems work, had this new philosophy, had this way of questioning and looking and saying, okay, well, there's a failure limit, I'm going to work on backing away from that, then the future would be a different place. So that's where that came from, recasting as a failure limit, which sounds pretty scary, but from talking with the climate scientists, it's extremely scary, actually.
Right.
So peak oil is the other side of it. You're right. So peak oil is the other side of it, that when we have a finite resource and it's consumed. So a reservoir of oil, there's a production curve that all reservoirs follow. It goes up, you invest more, you set up the wells, you pump them, and then it produces for some amount of time, and then it starts to drop off. So that's a known thing. And in the early 2000s, late 1990s, some petroleum geologists started looking at the world's oil resources and saying, well, this happens. This is a thing. And it sounded scary. And I think it sounded scarier than it was, because it was actually the solution to the climate problem, is this peaking of the amount of fossil fuels we use and then the decline of them. And so I think, lucky for me, I started working on, okay, well, what would that look like if we did it in a way that wasn't panic, or just like in the 70s when there was a decline in oil supply. What would our systems have to be like in order to actually engineer that decline in the amount of fuel that we need? And so I started doing calculations and getting data about how much oil we were using, what we were spending on the systems that use oil. And I found actually this huge treasure trove of spending that we are doing just to get from point A to point B, not to cure cancer, not to educate children, not to restore a mangrove swamp, not to actually do anything. And it's like a third of our budget. And I thought, wait a minute, there's this huge wasted resource here. This idea of peaking our oil consumption and bringing it down is actually a huge opportunity to take that money that now is just thrown out of our economy at the Middle East. Here, you guys take that money and build what would work, and how we would make things work in our own country, which is going to take a lot of engineering, but it's all doable stuff. So peak oil, for those of you who remember, it was a scary idea, but it's a scarier idea to not have it.
Right. Well, we'll talk about what were the solutions that they pursued thereafter, but want to just pick your thoughts on a population, energy demand, and consumption, and how do you see these three interacting with each other in the future?
Right. All right.
Well, just to put it in the context for the audience and listeners, there are separate chapters in the book on each of these things, but I'm just trying to get her to talk briefly, but I really urge you to go and read the book, please.
Right. Well, depending on where you are in the world, your population, your demographic looks quite different. Yeah. Depending on what generation you're in. One of the exercises I have my students do is to map out their family going back 4 generations, and look at the number of children in each family. And you'll see that changes dramatically over time. Sometimes it's been quite high when there isn't, well, shall I say frankly, when women have no other choice, then babies just come, right? And then when women have other things to do, then the number of children gets to be around 2 to 1.7 per woman. And that is a rather sustainable population rate if you have low infant mortality. Now, for a lot of human history, infant mortality wasn't low, so you needed maximum fertility just to keep the population stable. So population is a kind of thing that we worry a lot about, because we had this boom of it when our infant mortality went down. And the life expectancy does sort of pile up people, but they do die eventually. So you have this period of just a population boom. All right. And that, depending on how you look at it, seems kind of scary. And then you say, well, okay, well, all those people want to demand energy in the way that, say, Americans have, and therefore we're sunk, right? The future's hopeless. And so putting those things together with consumption behavior of different people in different places, the population dynamic, I think what people tend to want to do is just go to a different place. Just sort of like, I don't want to think about this because it sounds really bad. It sounds like an untenable situation. But here's the key. Americans and Europeans have way overshot the benefit derived from the amount of energy and consumption that they do. So they've pushed from a good life into an obese life, into an oversubscribed life, a no time for fun life, right? So they can come back. They're very low birth rates and very low fertility rates. Basically, they're like Japan. There's a lot of countries that are on a downward population trajectory. And then the places where the population is booming and there's maybe not really enough energy or food or materials for everyone, we really need to look at those places. And those are really big challenges there. But I think agency from the ground up is probably the way to go. There's no magic solution coming from above. And definitely trying to think about overshooting as a solution is not, like, reframe that. Figure out what you have to work with and rework from the local community upward to gain agency and autonomy and sort of the Oldstrom view of economics, where what the local area needs to do for its own sustainability comes first. That's the primary thing. Export earnings, selling our labor, selling off our stuff, we have a choice not to do that. And then people who are in true poverty, I think I'm lucky. I've been able to do research with remote communities in South America and the Pacific and Maldives. And what I've seen is that there's a giant difference between poverty and impoverished, and the physical poverty, you have to let those people define it for themselves. That if they have what they want and what they need and they're doing things their way, then you have to honor that. And when I see that people can't meet their needs, it's usually because somebody's coming to impose their economy on them. It's a sort of a colonial situation. So again, the answer is local autonomy, agency, and building of the economy that you want from the ground up. And that's transition engineering is actually there to help with that, because that economy is going to have infrastructure and energy use, and that needs to be done for those people, not according to the World Bank or according to anybody else for whatever they want to do.
Right.
That deep stuff.
But I think energy consumption only continues to increase, right? Because we'll find newer devices, newer gadgets. Earlier, what was vehicles run with fuel, which is, of course, hydrocarbons. But now, electric vehicle, but they consume more energy. They need more mining, so more processing. So it never goes down. Does it? Do you really think it will go down?
All right. On this side of the page, there's the word need. Right? And that word we might want to question, because there's lots of well-off white men saying they need electric cars. Therefore, we need to build the grid to fuel their electric car. And we need to put in charging points wherever they want their electric car to be parked. And need. All right, let's turn it over and see what the other side of need looks like. And again, let's not let those people completely run the conversation. Let's turn it over and look at where you are in your place and have a conversation about what need really
How
is.
do you change this conversation? Just a day before, I think a friend shared with me about a news report on how electric vehicle is so sustainable and all that. And there was a comparison of electric vehicle and a hybrid vehicle. So, and he was asking, what do you think? It was in a group, and I was trying to tell them that, see, I think, in my opinion, the conversation is completely wrong here. What is required is that what are we doing about moving more number of people or public transport? How is it? I mean, we are creating more roads for individual cars to drive, but we are not building enough public transportation where a group of people can move, right? And
Absolutely. No, you've
the
picked
whole
that one.
narrative is taken away by electric vehicle for individuals versus that whole public is lost. So how do you change this conversation?
Again, I think that is the work that we're doing here in our research center. And what we want to set up a network of transition engineering labs around the world where we can have these logical conversations. Because again, on one side of the paper is car. And on the other side is access. We need to get to our job. We need to get to school. We need to interact with the market. We need to get to a park to enjoy some fresh air. So there's the access to our activities. And if we design the world for the mobility of a few with cars, then we're cutting off the access of everybody else. So it's a design decision that there's nobody else who designs and builds that system than civil engineers.
Oh, I must tell you, India
find your
recently
city's
became...
civil engineering department and say, you all need to get trained as transition engineers because you need to flip the page over. You're taking us down a road that we can see where it leads. Good pun, huh? Look at an American city. We don't want to go there.
India has today highest number of roads. I believe we just overtook China. Motorable roads. And I think we have possibly the highest amount of toll roads. So if you go to most of the toll road, it essentially keeps people who can't afford much out of the road because they are dependent on public transport. You want something you can't get. You want faster access. You have to drive your own car and you pay the toll and you drive on the highway or the speedway or expressway or whatever it's called. But it just keeps... So biggest of infrastructures are built in the country to cater to very small percentage of population. So
right.
So this is called sustainable development again.
Right. And those are political
Sustainable growth.
decisions, right? Because they're big money spends. So they're from the top down. They're about the political decisions, talking ourselves into that if we build this road, we're going to have economic growth, yeah. And so the only counterfactual to that I've found is that they can't build it themselves. They actually need the civil engineers. And just like a politician can't demand that a chemical factory be built in a way that will kill 10 workers a day because they think it's a good idea, right? Or whatever, because the chemical engineers who run the factory won't do it. So the civil engineers learning transition engineering, learning how to look at things as a whole system, design for the actual need, which is the access to activities of all, that is leading to a different future. I understand how we got the one we've got now. I understand that this, the public money, the suiting the elite, that spending that money for the convenience of the elite. I understand it. but there is an antidote to it, and that is social responsibility of the people who actually do the designing and building.
Perhaps you should open up your programs for policymakers and bureaucrats, because I think they need to understand this. See, we have a system where people are into town planning department doesn't understand that congestion on road is directly proportional to the congestion of population in a locality. When they give permission for 100 tall buildings and then they say the roads are small, it is logical that it is bound to be small for the population you have allowed to be located there. So they are not connecting that if we give permission for this many tall buildings to come up here, it is bound to contribute to the traffic tomorrow. So what we need is people who are able to look at everything. So maybe you need to take your program and offer it to policymakers, because they need to understand. They need to understand that if there are more people going to live there, that means the more people are going to use the road. So more people are going to use the road.
Right.
You need to have better planning for roads and not planning roads for cars, but roads of commuting. So I think somewhere
Right.
the
Well,
way
you were
we
just
approach
talking
things are
about
things.
you were just talking about that there's a lot of the engineers in India are going into software.
Correct.
Well, one of the research projects that I'm doing here is actually modeling of human access activities. So that you can design cities or take what you've got and re-engineer them so that they just work. Because you have to start with what you've already built, because what else are you going to do? And that is some really interesting modeling that isn't really done, and it connects up those things, like you say, the where you go at night, where you go during the day, and what's in between. And you just see that whole idea of the personal automobile being the way that works is mad. It's just
Good.
Yeah. But
So
a lovely city that works is what's out there for us to pursue. So let's do that. And to do that, the politicians, their understanding of these complex issues is very narrow. They're getting lobbied by people who want to build a tall building. Right? I want to build a tall building. I want to make a lot of money. They're getting lobbied by construction firms that build roads. Yeah, we'll build a road. It'll be fine. We'll build a road. And what's complex is how people actually live and move through that city. And nobody's advocating for that. Who's going to sell that to the politicians? So that's where I'm saying, let's put that in the discipline bucket, where the people who design those systems have to do it right. Let's get that research done quickly. Let's get right in there and get that done. So a urban transition engineering center for India might be indicated at the moment. America needs some too.
Wonderful. I think there are few people working on it, but maybe I'll be happy to connect them with you as well. And hopefully,
a lot of them are like urban planners.
Look at
where they're saying this doesn't work. This doesn't work. This doesn't work. Okay, let's flip that over and say, okay, what are the tools that we need to design what would work? Right. So connecting things up, yeah. Correct.
So I just want to step back from the earlier conversation where you were talking about oil peak, and so that's where we needed a solution. So how much of biofuel, in your perspective, is relevant and sustainable?
Right. Well, that you can find some engineers to do some calculations for you. We had that, the fuel price run up, the peak oil situation, and a lot of governments reacted to that by saying biofuels is our answer. That's our solution. Right. Apparently, without ever asking, well, didn't we do this in the 70s? We already did that, right? Now, they didn't ask that, which we had, so we already knew. But then without ever asking someone to do some basic calculations. So I was in New Zealand then. And so we sat down and we looked at all of the agricultural land, what it produced, the the efficiency of converting those products into biofuel, then looking at if they're processed in New Zealand or if there's a waste stream. New Zealand had good statistics on the tons of different kinds of kiwi fruit skins, because the juice was actually made here. So we took those and looked at the efficiency of putrescible gas conversion or ethanol conversion. And we just calculated for the economy of New Zealand, if we converted all of the biogenic waste streams into fuel, what percentage of our fuel could we replace with biofuel? If we converted all of our sweet potato, corn, and wheat crops into fuel instead of food, what could we produce? And then if we converted our land to rapeseed, which the biologists tell me that once you plant rapeseed somewhere, so that's the canola, that it cross-pollinates with things, and so it'll destroy the ability to produce seeds from anything that's within many kilometers of the rapeseed. So that's why, I guess where you grow the canola is special areas. So if we give up our status as a rape-free place where seeds are actually grown for the rest of the world, then how much biodiesel could we produce? And so using the facts and figures for New Zealand, we did those calculations, and we published that in a paper in the journal Energy Policy. And you see that New Zealand could not get above 8% of its current fuel use, with all having no more food, basically. And not the amount that farmers now get for export. They'd have to get a very tiny amount of that for fuel, because the value of the fuel is much lower than the value of the food. And so it's an absolutely mad idea. Like why did you think this was a good idea to pursue? There aren't going to be any farmers who are going to do this. Hopefully we'll stop the rape planting before it gets out of hand. And I presented that paper at a national conference in New Zealand, and right before me was the government spokesperson who gave this, the government's going to do biofuel and we could run our economy on our own biofuel. And she's just like spouting this stuff that had no basis in reality. And then I got up and went through the numbers and basically said, oh, she's full of it. But yeah.
Have they changed it?
So what about biofuels? Yeah, well, it went away, didn't it? I mean, it didn't make any sense. So it was never going to make sense. It could be the government policy. And you can find a picture of Helen Clark opening up a forecourt where one of the fuel companies was selling some biofuel at this forecourt. And it was just performative governance. It wasn't a real thing. And so they put a mandate on for a while that New Zealand was going to have to mix biofuel in. And then they figured out they couldn't actually make it because none of the farmers wanted to do it because they would lose money. And so, we'll import palm kernel oil from Indonesia. Where they're wiping out rainforest to plant palm kernel. And that's sort of where, it just sort of quietly went away as a policy.
That's good at least that it went away, but it is very much in practice still. Yeah. In fact,
it'll come back. It's come back in New Zealand. It'll keep coming back, even though there's these. It's very easy to do the numbers, and that food or fuel, that is that's a hard stop. That we have to be very careful.
This is where I just want to recall my first question about. Why do you want to question the sustainable growth? Because this is the context. In fact, unfortunately, biofuel is paraded as one of the means for sustainable growth. So that is what you meant to question the sustainable growth. So I just wanted to complete the circle here in the context when you started the conversation.
That's the thing we call a crash test. You just find somebody, go to your local university, find somebody who can, do some numbers and put the numbers to it and see if it matches the story, because it's very easy to create a story and get some graphics and get some talking points for the politicians, and especially to give subsidies to companies to build a ethanol plant or something. That, the United States did that. They took all this surplus corn.
It's done here in India as well.
Yeah. So a methodical way to question the story, and then I guess wind that down. You've built an ethanol plant, and who is that actually benefiting? Probably the food prices are going up because there's some stream of food that's now going into that. The other thing is those things use a lot of water. So I don't know if you've got lots of surplus water.
That's another.
Worry about that.
See, there are many people who write about it, but one of the things I found very good about your book is that you actually address every aspect of it, including water consumption. In fact, many people have actually left it out, from my observation.
Yep. And then how hard you're working the land. And if you just make that connection, which I think I put in the book, the calculation of corn ethanol, that's the best resource for ethanol.
Well, some researchers have captured the land usage from a renewable energy point of view. But what is missing in my observation is the water usage. So I think so that's another reason why to the listeners and audience, you should look it up. There's a lot of statistics, data, and also infographics.
Right. So there's a lot of things in our sustainable growth economy that we have to stop doing because they weren't good ideas. So the only way to tell if something wasn't a good idea is honesty. So a thing that we transition engineers agree to be honest. And then don't do any more of it if it doesn't make sense. Let's try again and see what else we can come up with.
One more thing I wanted to ask you. I think you also make this a point in terms of depletion of natural resources and even from the hydropower plants, right? The topsoil erosion, which actually takes away a lot of mineral value out of water also. So not just the energy consumption side, right? While from an energy standpoint, hydropower plants are observed as one of the sustainable ones, right? From a sustainability standpoint. But what is ignored otherwise is that it actually erodes a lot of mineral value out of it. So that is another thing which remains the challenge. One definitely has to look at it. So are there any research you have looked at, or research data you have come across on that front?
Yeah, there's been papers done about when a hydro reservoir is built, how important it is to clear all the vegetation out of the reservoir before it's filled, because the methane produced by the rotting vegetation essentially makes that absolutely not a low carbon electricity source.
Good.
So there's that. And then, of course, like you said, you stop the siltation, the nutrients from coming down the river and fertilizing the floodplains. There's a lot of things that we do know, and we can now observe in retrospect, like especially the Nile, the damming of the Nile, and in America, the salmon runs being wiped out by the dams. And it seems like there's a bigger picture here, that when we look at it, we should learn. Is it possible that the anthropologists are right, that every time humanity has faced a new challenge, and a lot of times that challenge comes from a new technology, or from climate change, like the glaciers, the ice ages would force humans to change what they were doing, and therefore adapt and come up with new things, new tools, fire, these sorts of things, that when we have a new challenge, we actually evolve a new capability. And this challenge we've got now is our own ability to run ahead of what is safe and sustainable. That we can talk ourselves into, oh, this is economic growth. Oh, this is this is a great thing. And we can just jump forward and do it. And so right now, can we evolve a way to sort of hold onto these great ideas until we've tested them out in a systematic way, at a sort of corrective loop in our development decisions? I think I see those corrective loops in traditional economies, that ability to just wait, to not rush into things, to make choices. Yeah, that looks great, but I don't think we're going to do it. No, that the risks are too high. And traditional people have a hard time explaining why they don't want to do a thing to people who want them to do it. but that ability to sort of manage our expectations and manage our forward run, that is what I hope transition engineering can start. It's a whole system discussion. But let's, if we can get together and start that process, we're going to need it for the long haul. Because of our capabilities now, we're going to need this ability to sense check and to systems check and to future check what we think is a great idea right now before it runs away. And that is step 7 of the transition engineering approach.
All right. I just want to have 2 more conversations on the energy side. So the last but one would be on the renewable energy. So that is another a flag bearer for the sustainable development and an alternate to the carbon fuel, right? So how do you want to present it? I would urge, obviously, audience and listeners to look up the book, but maybe a quick perspective.
Right. Renewable energy, we're saved, right? And there's a lot of podcasts on that, wind is getting cheap and it's growing super fast, and solar's cheap as chips and it's growing super fast, and batteries are even getting cheaper. So we're done. We're saved, right? Let's check that. Let's do the numbers and let's look forward. Let's build a simple model where we put on what growth rates or whatever, and let's make sure we keep track of how many mines that's going to require, and how many fab facilities, and how much input output it's going to need. Like, to build a solar panel, you need this much aluminum, and can you produce aluminum from solar? So let's look at this whole system, and let's run forward at least 100 years with that system and see where it takes us. And essentially what I'm going to say is that renewable energy works. Renewable energy has always been what humanity has used. The sun, the water, the wind, we've always used it. So of course, sure, we can run a civilization on renewable energy. It's that page full of the word need that we need to have a look at, because that world run on renewable energy right now, it's looking to me like we're talking ourselves into another runaway train where we're just going to throw renewable energy up and throw batteries up, and it's going to separate the prospects of people even more. There's going to be the elites who have access to that, and all the others who have access to going and getting jobs in mines. It's going to, this runaway train effect, I think, is in very much danger of getting going in the renewables area. It's not good, no matter where it's happening. There's no inherently good technology. The good technology.
What beats me is, why is it people don't look at a life cycle analysis view to these things? The researchers who advocate this, why don't they look at it? Because I remember first time
they do, and then they compare it to fossil fuel, right? The life cycle analysis of a solar panel, the energy return on energy invested. We can look at that. We can look at the materials used. We can look at that. We hope it'll be recyclable, but that's not really what we're looking at the moment. And so, we just talk ourselves into boarding this runaway train. And that part of that talking ourselves into it is, we compare it to fossil fuel, right? Compare it to coal. It has lower emissions. Well, lower isn't what we need right now. We need a downshift of emissions. So do the calculations and see if what you're talking about gets us there. And there is no set of calculations on the planet that shows that we can get to the backing away from the failure limit by just increasing renewables. There's a massive downshift in fossil fuel needed, which brings down the total energy. So that world where we've reorganized ourselves to not need energy that we can't afford and that the future can't afford, that's actually the project. And that's a pretty simple project statement, actually. So maybe I need to work on how we talk ourselves into that.
Well, in fact, the significant part of the Europe already it is quite divided in the nuclear argument, right? So, in UK included, is more for renewable and less on nuclear, and Germany has been leading this argument for some time. So, what's your take on nuclear in this context?
Right. Again,
where do you stand?
Nuclear power is a thing. We were talking about earlier that the things that are the biggest threat to our future, our children, our grandchildren, our great-grandchildren, are things that we have no control over. We didn't build them. We didn't design them. And nuclear power is the epitome of that. How many of us actually have one bit of say about nuclear power? Nuclear engineering, nuclear development is necessarily a completely top-down activity. The French are now finding out that 50 years in, you can lose your capability to do this, that the end of life of those plants means end of life, when end of life means end of life, and that you can't just keep them going. And so that long-term view, where we were going to have ways to deal with the waste. The other thing is, look, where is the fuel going to come from for these nuclear power plants?
But the raw materials in use is very small. The waste is also significantly small compared to any other resource, right?
Right, and that's not how risk works. You have probability and impact. So the fact that the volume of waste is small doesn't preclude the fact that the impact over a particular amount of over an infinite amount of time is massive. So I don't know. It's like nuclear. It's a symptom of our inability to manage our own sustainability. It really is. It's one of those things that it is what it is. Like the nuclear system that's already in place, the nuclear power plants that exist, the tailings piles that exist from the original mining and milling, the uranium hexafluoride gas that's sitting around, the contaminated sites that exist, the piles of spent fuel that exist. All of these things that already exist are some of the biggest challenges we have to manage going forward. So building more of those, what problem was it we were trying to solve? Is it a way to manage those risks we've already made? It's just, I know people want to know that there's a solution, right? I just want a simple solution, and I want to have a political position on that I just believe it, and I don't want to talk about it anymore because it's all complex. But nuclear is one of those things that you'll just get yourself into a round and round spiral of not actually having any impact anyway. So move on to what you actually can do.
Well, so what's the best energy ROI in your perspective, then?
Okay. Energy return on energy invested is a concept that is coming out of biophysical economics, which just says, okay, there's the economics that's in the human thought space of, value of time and money and consumption and stuff, interest rates and whatnot, which is all human constructed, right? And then there's the physical world, where if you're going to grow food, you have to plant and, harvest, and you have to actually do actual work with actual soils.
The X number of process, it consumes Y amount of energy.
Yeah. So if we think about the world in that context of the actual physical trade-offs, then the amount of energy that we have to take from the economy in order to build an energy system that provides energy to the economy, that's like an investment, right? So we invest energy that we could have used for something else into a system that gives us energy that we can use for something else. So we need a return on that. We need an energy profit, so to speak. And what I'm pretty sure of from digging into the numbers is that hunter-gatherer societies have an extremely high EROI. The amount of energy, so food and labor that they put into the systems that return energy to them, like fire and food, is very positive. Maybe 80 to 100 to 1, right? So if you look at what anthropologists have found about the amount of time that hunter-gatherer societies spend working on those sorts of things, it's actually not very big. So we think of them as eking out a survival, but it's actually a cushier life than a factory worker or something. All right. So then you get to now the next one is farming. So if you're going to now try and make land work for you, depends on what land, depends on where it is, depends on what you're farming. You have to have inputs to that. But that is also a very huge return on investment, food. And wood, if you have a wood lot and you have to keep that forest going, because that's where your wood's coming from, the work that you put in to keeping the forest going is kind of management and then some chopping and moving. It's a really good return on investment when what you need is energy for cooking and for heating and for materials processing. Well, once you get to an industrial society, that gobbles up all your wood, so it makes an end to the renewable resource, and you use all of your hydropower, and that's limited. So you get to that state, and then you have to go to coal. And so that return on investment of using coal for industrial purposes is, again, really quite high. It's just a lot of very intensive free energy sitting there. You go get it and put it in, and it works. Now, when we get to something like oil, that has quite a high energy return on investment. The question is, what are we investing in? Right? So we tend to waste a lot more of that than we did with the coal in industrial, materials processing, making cement. We're actually making stuff that we then use. But oil, we're sort of just burning it and having a good time. And then you get to gas, which we do use for heat and for manufacturing. And when you get, then you want to come back and you want to run an industrial world on biofuels. What you see is that mismatch is completely wrong.
We also have petroleum products, right? Plastic and a whole lot of other things which are including that straw and the cup.
Well, usually thrown away. That's right. You're making an amazing material just to throw it away. That's this sort of mad world.
But application goes everywhere, right? Clothing to medicines, to packaging, to pretty much everything.
Right.
So,
well, if you think about that mineral resource, the hydrocarbons that exist as a mineral resource for things we need, and you start working out, okay, how much of that stuff that we make is actually in the need category, you start to see that a downshifted production of those mineral resources to fit a society that just isn't mad that is sustainable, that's the project. So
Mm-hmm.
not how do we feed this overinflated runaway train of a technological enterprise-based society with what's left of the remnants of biology on the planet. Let's throw that in.
Right.
But more like downshift that to a survivable and servile. Like, let's make, if you imagine energy and materials being the servants of a good life, it just is a different philosophy, a different way of applying the same knowledge. And that space, to have that space to design those different systems and the transition to them, that keeps me actually hopeful, I have to say.
Right. Well, in fact, there are a lot more things, but as a last question in this section, I want to ask you, how do you propose to address the popular narrative versus reality? I think you spent a lot of time in trying to put that together in the book. So maybe, and also the aspects of it influencing in the policymaking.
Right. And this is top of mind because we all expect our policymakers to work for us, to make good decisions, to take action, right? And I don't think that my approach to that and the transition engineering approach to that comes from a defeatist or cynical way of looking at it. I think it comes from a realistic way of looking at it. The first story in the book is the story of the Titanic. It's a thought experiment. If we had a time machine and I put you onto the deck of the Titanic 24 hours before it hits an iceberg, could you save the Titanic? What would you do? What actions are in your repertoire? Could it be the information that you have about the future? Would that change? Would that save the Titanic? Would that change things? And I think that's the quandary that the climate scientists find themselves in, is that they have information about the future that comes from pretty reliable and tested and modeling. And they're trying to show us the catastrophe coming, and it's not changing anything. It might get some of the passengers worried, but it's not doing what they thought it would do. And then we all expect the captain to just, look at that information and just slow down the ship. The ship's going full speed into this iceberg. And the other ships in the area actually radioed the location of that iceberg to the Titanic hours before it hit it. So should we expect our political leaders to take the pertinent information and take the appropriate action? And I think that's where we see the breakdown of that expectation, that even if you and me are on the deck of the Titanic and we've got 8 hours to go and we know exactly what's happening, number one, I don't like our chances of finding the captain to try and talk him into slowing the ship down. Do you?
Oh.
Yeah. Could we go talk to our respective prime ministers? I'll go talk to Sunak here, and we'll talk to him about it's a little hopeless, doesn't it? They're driving this ship the way that all of their information says to drive it, and they're very proud of it. It's a brand, it's the latest technology, yada yada. And they're having dinner with the first class passengers in the first class lounge, and you and me ain't getting in there. So that expectation that it's the political leaders or even the owner of the ship who, they're going to lose their investment if they keep this course going. But we can't, what are the odds that we'll be able to convince them to tell the captain to slow down? Because their whole, they're just in their own bubble up in the first class lounge, having dinner and dancing and having a good time. So could we get the, all of the third class passengers who are just working people having to give up their homes because they can't live in Europe anymore, and they're trying to get to America to get to factory jobs, and they're just trying to survive this 4-day journey. They've spent everything they have on it. Can we get them to protest, go up to the bridge and occupy the deck or something to can we get them to take action? Because what action do they have? They can't captain the ship. They definitely can't go talk to the first class people. What action can they take? Well, they can protest if we can wake them up. I mean, I don't know. So is their protest going to change this journey? I wish it did. I wish that was an obvious yes, but I'm not sure I would bet my life on it. And so my story of where transition engineering sits in all this is that we've got, 3,000 people on this ship, and 50 of them are making the ship go so fast that it's going to sink when it hits the iceberg. And those 50 are down in the bottom shoveling coal. And all we need is for them to reduce the amount of coal they're shoveling, and the lookout will see the iceberg. The captain will call for a full throttle change to the right. The passengers will go, whoa. So for me, the 2% of the population that are driving the actual thing, that understand that this system is not immune to catastrophe, and that the catastrophe as explained is possible, and that the only action possible is to slow it down and change direction, that possibility that the engineers who make it run away could actually save the day has a much higher probability to me than that our political leaders will somehow. I mean, I don't think they're getting better. Got to say that. They're understanding. They might say sustainability more, and they might, but it just seems to be just driving us harder in the direction that we're already going. Right.
Well,
so,
what do you think? What would you do? Would you be able to go reach the captain?
No, I really don't think so. I mean, if I could right now today, get a meeting with Rishi Sunak. We'd sit down, have a chat, and I'd explain to him, look, here's how this all works. And I know it seems like it works the way that you think it does, but the shift to where the UK is doing fine and everything, it requires a national effort, kind of like a re-engineering of everything, but that's okay. We can actually do that. You just give the impetus, and he'll say, well, we're doing hydrogen. Yeah, I know that. We're spending $3 billion on hydrogen. Yeah. And that's the thing. Let me show you some numbers on that. Right. So far, me getting to have a chat with Rishi doesn't look great. Me being able to make the argument that there's a different way to look at this. Let's flip that over. Possibly. He's a smart guy. He understands counterfactuals. But then the political positioning that politicians have, that the announcement we've already made is correct. Right? I'm not going to back down on that. I might quietly go over here to a different announcement, but I'm not going to rescind an announced policy. That's just not going to happen. So I don't like my chances that much, right? The plan we have is what I've announced it. I'm the captain. That's what we're doing. It has to be right because I said it. So yeah. So like I said, right now with the time I've got, if I can teach a new thing to engineers and that can spread the way that safety engineering has spread, the way security engineering has spread, then what we'll see is that businesses and governments will start demanding that, because they'll see that it works. They'll see that new safe direction that we're going, and they'll start announcing that that's what we're going to do, and that'll be fine.
Wonderful. Well,
people don't listen to your podcast, do they?
I don't know if political people will listen, but hopefully, we've had some interesting conversation on hydrogen as well, and our Minister for Road Transport had made a commitment on investing in hydrogen. So I did tag that podcast to him. I didn't hear from his office or him either. So I don't know. I don't know if they're getting to listen to it. I don't know if it is getting filtered out by his office.
Well, what I've
So,
just told you, I think, is a fundamental property of political environment, which is that once we've announced something, we aren't going to talk about it anymore. We're not going to question it. So don't try that. So you can possibly introduce a better thing and get them to announce on that. But yeah, right now the
well, I
thing
don't
is
know. See, this man, this Minister for Road Transport who announced it, he's also an entrepreneur. I primarily believe that entrepreneurs are not averse to stepping back on a decision made because, we entrepreneurs understand we make mistakes. And most important thing is that I understand it soon enough and correct it. So if I don't agree with
well,
that
maybe
I have made a mistake, then I won't make it far. So
maybe you have
so
a
from
chance
that
there then.
context, but only thing is it should reach him. I don't know if it gets filtered out. So the same thing what you mentioned. So, but yes, it's interesting times, and that's where I also keep making a lot of arguments, and I also write about this particular thing. I did write some blogs on popular narrative versus reality. I also talk about life cycle analysis. So every opportunity that I try to talk about it, at least get people to start thinking in that, approach everything from an LCA point of view, so that don't just get swayed by whatever the talk. Before it gets to your table, how much of energy has it consumed, right? So there is a lot more has consumed, and if it is done more than 10 years, even before it gets to your hand, then you think, is it really sustainable? So, but yes, we surely need this, and to the audience and listeners, whatever you heard, the book has a lot of graphics, a lot of statistics, research references, and infographics, and interspersed with a lot of interesting stories, like she just mentioned about
Thought experiments. Yep.
the thought experiment with Titanic. So you will find it interesting, and do share this conversation, and also look up the link below this podcast, and come back soon because we're going to talk to her also about her perspective on future. And until then, if you're not subscribed, subscribe to Future Fast. And once again, Professor Susan, thank you so much for doing what you're doing and being here with us as well.